Hi. So we're going to talk about transformations of variables in our machine learning class. So this is about either changing the columns in the matrix X or possibly adding new columns to X, and the effect that that has on your ability to do classification and regression. So we're going to do regression in a different lesson. This one is just going to be about classification. So we can skip over to the slides here. Whoops, that's wrong. Well, we can look at this this also. So this is just the equation for a circle, and you might know that if you alter, can I draw here? Where's my pen? There it is. You know, you can add coefficients here too. Like if I put a 7 here, then this will sort of exaggerate things in the direction of the y-axis. So this is sort of just the formula for an ellipse, and this thing that's supposed to be an r is the radius. So that's just a reminder of some high school algebra. And let's sorry, I need to come back over here to my studio. So now let's go through these slides. I want to talk you through a variable transformation here. So what's going to happen here is we have a non-linearly separable set in the original space, the original input space. So it's a two-dimensional input space. So this is a binary classification problem, and some of the points are classified yes, and some of the points are classified no. And so you can see pretty clearly how that works. And this is just a toy example. I've set it up so that the positive examples are inside the unit circle. And so here's the ellipse. In this case, happens to actually just be a perfect circle. So here are the points. This is something that is normally random. It's distributed with a normal random distribution, and it's got n rows and 2 columns. So this is sort of like, you can imagine, if you want to visualize the probability distribution, it's sort of like a mountain sitting right above the origin here. So there are 200 of these points, and this just gets the this ellipse will be a binary vector. So it will, sorry, it's like it's true and false values, not zeros and ones. And so it just says which for which coordinates is it true that the point is inside the unit circle. So we'll take the points that are inside the circle and call them the positive instances, and then call the ones that are outside the negative instances and make a scatter plot. So there you go. Now we're going to do this transformation of variables. So we're not going to add any new columns in this example. We're just going to transform the columns that we have. So the this 1 here is the bias column, and I know I'm saying column. You guys know what I mean, right? When you put this is a data point. When you put it in the X matrix, you take its transpose. So naturally they want to stand up straight, and we kind of force them to lay on their sides when we put them into the big data matrix. So what we're basically doing here is just squaring the entries in each column. And when we do that, the data set becomes linearly separable, because we know the decision boundary can be expressed like this. So this is like the equation for the unit circle, but I've just moved the 1 over to the left. And so that decision boundary can be realized as the dot product of a weight vector and this this new instance vector. So maybe that's a little bit confusing, so we can come back over here to this other scene, and let me give you a fresh piece of paper here. And so let's just say W is equal to, this is W bar, is you know, W0, W1, W2, and X bar is equal to, I'm just going to kind of express it in terms of what was there before. So there's the bias, which is always 1, and I'm going to write this as x1 squared, because this is the this is sort of the image of of the original coordinates. The book uses z for this, which is probably wise. Yeah, so let me do that too. It's going to make this a little bit longer, but that's okay. So this will be like this, right? And then z is going to be a certain transformation phi of x. I'm using the notation of our textbook here. And the transformation is x0, x1, x2 as a vector goes to x0, x1 squared, x2 squared, and this is what we will now call the instance z. So z is sort of the transformed version of x. This kind of also introduces the notation. Our textbook likes to use this uppercase phi to represent the transformation. It kind of looks like the green lantern, charging lantern. All right, so now in whereas we couldn't create a linear, if I do w times w dot product x in the original space, this will just give me a line. But now if I do w times z, then I can get all kinds of ellipses and circles if I plot them in the x-axis. So for instance here, if I just do like, what do I want? I want to kind of express, here let's write the bias over here. So I want x0 x1 squared plus x2 squared. So if I set this equal to 0 and I make this negative, then this sort of is the this is the decision boundary for the circle. Because it's just the circle, this is the bias coordinate, so this is 1, and we've just taken the equation for the unit circle and moved the 1 over to the left-hand side. Okay, cool. So now if w is equal to negative 1 and 1 and 1, and then I do w dot product z, then what I get is exactly minus x0 plus x1 squared plus x2 squared, and then where is the decision boundary going to be here? It's going to be at 0. That's because, how do we do the classification here? We take the sign of this, right? So the important thing for classifying points is the sign of this expression. So the sign is going to change at 0. So where it's equal to 0 is where you get the boundary. Okay, so now let's go back over to the other scene. And okay, so we'll go down a little bit further and we do the transformation. Notice it's very easy to do in numpy. All you do is just literally square the thing, because you don't need to square the bias, because the square of 1 is 1, and this just squares the x's and y's. And the same, you can use the same truth vector, Boolean vector is the word that I keep looking for to get the truth values here. You plot them and now they're clearly linearly separable. So that was maybe a little bit tiring. I've been told that I should stop these after a few minutes, so let's stop this and then you can go get a cup of tea and we'll have a second one coming up.